So, who are new to the video, I'll just say this that I'll be making different playlists for different sections, that is for arithmetic, algebra, geometry, and modern maths. So, just follow the playlist and we'll be solving a lot of questions of with various difficulty from easy to difficult. So, let's start with this question. It's given that log CA is equals to 1 by 2 and log dB is equals to 1 by 3, where a, b, c, d are distinct natural numbers. What is the minimum possible value of a plus b plus c plus d? Okay, so first of all, it's given that log base c argument a is nothing but 1 by 2, and similarly log dB is nothing but 1 by 3. And a, b, c, d are natural numbers. So first of all, you need to know a property about log. For example, if it's given that log base x and this is the argument y is given is equals to something z. So you can, if you want to remove the log, so how can you write this as y would be here itself and x would just go here in here and it would push the x in the power. So y would be here and x would go in the place of z and it will push z in the power. Okay. So if we try to apply this logic here, so a would be here and c would be 1 by 2 and b would be here and d would come in place of 1 by 3 and would push 1 by 3 here. Okay. So let's square this. So a square is equals to c and b cube is equals to d. Now, what do we need to calculate the minimum possible value of a plus b plus c plus d? We need to calculate the minimum possible value. Okay, so uh, so we need to calculate the minimum possible value. In place of c, we can write a square. In place of d, we can write b cube. If we assume, we can also assume, but if let me substitute and just c from b, and in place of c, I'll write a square. And in place of d, I'll write b cube. So a square plus a gets common out, we'll left with a plus 1 and b squared. B gets common out, we'll left with 1 plus b squared. Okay, so still we aren't getting a cube plus b cube. We can apply the identity and we can get something, but given that a, b, c, d are distinct natural numbers, we'll just substitute something. We'll take d to be 1, so a distinct natural number, no? So b cannot be 1 because yes, b cannot be 1 because 1 cube, they're different. So we have to take different values, no? Mm. Okay, so let's take it to be 2, and then this is 2 cube, that is 8. 50, sorry, wait, yes. Let this b be 2, and then d would become 8, and let uh, let a be let a be 3, then it would become 9. So if we add this now, 8 plus 2 is 10 and 9 plus 3 is 12. So the minimum possible comes out to be 22, that is option number 2. Okay, so why have you taken 2, 8, 3, and 9? See, distinct natural number. It was given that they are distinct natural numbers. The natural number starts from 1, 2, 3, and it goes on. If I take 1 in any of the terms, for example, if A, B, C, D, I'll consider 1. So 1 square is also 1, 1 cube is also 1. So they would be not distinct natural numbers. So we'll just ignore 1. We'll start from 2 and we'll take 2 in the cube because 2 cube is 8, and if we take 3, 3 cube would be 27. And we need to minimize, no? So we'll take 2 cube, b to be 2, so b cube is 8, so d is 8, and a to be 3, and a square is 9. So that would give us 10 plus 12, that is 22. That is the answer for this question.